According to the Flight Safety Foundation, about 30% of all aviation accidents occur due to spatial disorientation. This suggests that disorientation still remains a killer in aviation. The whole range of recent air crashes that occurred due to abnormal circumstance on set came to the tragic end for the sole reason that crews faced complete or partial disorientation. In the wider industry, it's obvious that aviators need to develop resilience by improving their spatial orientation skills and overall situational awareness, both in IMC and even in simple VMC conditions, in all phases of flight, including the takeoff, approach and landing. The aviation industry has long been concerned with addressing problems related to spatial disorientation. However, given that accidents continue, we propose to introduce new training methods to address this issue, starting at the level of the PPL. Modern trends in pilot training. CA pilot training has always been based on theories and concepts stemming from academic research results and training practice analysis. The new training method, proposed by the pilot instructor Konstantin Yermoshin, is no exception. Based on the flight image concept, the method helps to rethink traditional pilot's training and allows student pilots to develop their flight abilities to the required level in a goal-oriented manner. They will learn to understand under any circumstances what is happening to the aircraft and in what position it is located in relation to the surface of the ground. In our context, we will determine that by flight abilities we will understand a skill which allows us to perform two independent actions together: piloting an aircraft and conducting spatial orientation, using all incoming information for these purposes, both instrumental and non-instrumental. According to our reckoning, the CA pilot initial training, using non-instrumental together with instrumental signals in an instrument flight, is a fundamental step without which the professional development process is being protracted over years. This point of view is confirmed by aviation psychologists. They claim that the training absence which would afford to model the flight image purposefully leads to its spontaneous formation and requires at least 7–10 years of flight experience beyond visual line of ground sight. This lack of attention to efficiency in training is inexcusable. First, because it's inefficient from an economic perspective, and secondly, because it's unsafe. This is evident when one considers that many experienced pilots with an excess of 5,000 hours display insufficient professional competence in dynamic flight situations when lacking reference to a visual horizon. Flight image. When flying in an overcast sky or at night, an experienced pilot should always be able to visualize his location relative to the horizontal plane, that is, develop a flight image of his position relative to the horizon. One difficulty that pilots encounter, however, is in correlating information derived from aircraft instrumentation with non-instrumental inputs, such as acceleration forces, control forces, noises and vibrations. The attitude of aviators toward these non-instrumental signals is ambiguous. The usage of the signals in visual flight doesn't complicate piloting. These sensations are easily recognized. They generally assist the pilot in understanding what is happening with the aircraft and cue the pilot cross-check their instruments, making pilots more confident and more effective. On the other side of the spectrum, when a flight is performed in inclement weather conditions, at night or in clouds, non-instrumental signals are less clear. If the pilot does not cross-reference the aircraft's instruments, these signals can cause a variety of visual and vestibular illusions, resulting in a misinterpretation of the pilot's position in space. However, even in IMC flight, it is impracticable to completely abandon non-instrumental signals. They are extremely important. They can offer timely warnings of various hazards, and they can assist in recognizing emergency situations when the pilot is receiving conflicting information from the instruments. We propose that information derived from aircraft instruments and information derived from physical sensations and perceptions are both critical in the formation of a holistic flight image, and that if used together, they can effectively neutralize the factors that cause visual and vestibular illusions and spatial disorientation. The ability to model a full-scale flight image is a matter of practice and only occurs when a pilot has developed all the necessary components, understanding of spatial positioning, an effective instrument cross-check, and an understanding of the physical sensations experienced in an aircraft. It is through the interaction of these three components that pilots develop their flight image, the picture of the aircraft's motion through three-dimensional space that exists in a pilot's consciousness. In this case, such pilot can be called excellent and that he has developed his flying abilities. Brief description of the proposed training method. Our training program consists of several phases. The first phase of training is academic. Student pilots learn to identify the instrument readings and the physical sensations associated with all standard phases of flight and unusual attitudes – climbs, descents, orbits, spirals. The trainee will be able to describe what he sees and feels in any of these situations. More importantly, he will be able to identify the aircraft's orientation based on given instrument readings and sensations. The theoretical knowledge is a prerequisite for the next phase of training, in which the students will begin to experiment with their newfound academic knowledge, using modern technology in the form of personal electronic tablets. The next stage of training includes classic exercises in which students walk through typical flight sequences. In our training, however, they concurrently view both a dynamic display of correlated real-time instrument readings and visual imagery representing the aircraft's attitude on their tablets. This allows trainees to form mental connections between the academic knowledge gained in Phase 1 and the practical skills needed to fly an aircraft safely and effectively. In effect, the trainee creates a mental model of what he will encounter in any flight. During this phase, the number of variable parameters gradually increase. When the trainee is able to track their spatial movement, monitoring more than 4 to 5 parameters simultaneously, physical inputs are added to the training regime for creation of complete flight model. This can be done in a simple or complex manner. In its most simple form, students simulate light acceleration at the moment aircraft flight parameters change by carrying out physical movements. For example, when simulating the initiation of descent, the student will sit down slightly, thereby creating a feeling of negative G, preparing for the conscious perception of non-instrumental signals in flight. In a more complex form, technical devices, such as full flight simulators, can be used to create these signals. In the final stage of training, trainees learn how to apply the skills in an aircraft. They already have a mental model of what they will encounter in visual flight. They now practice consciously combining their visual out-the-window perceptions with both non-instrumental signals and instrument readings. The mental model has already imprinted in their memory during earlier phases of training, which is a key in developing of flight abilities. As the trainee completes his training, they will have gained the ability to take all these different inputs and interpret them as one integral signal. As a result, they will be able to identify any regime of flight instantly by comparing the incoming information with sample images planted in their memory. Today's reality. In modern aviation, widespread automation of control and equipping with advanced instrument indication systems create the impression of flight in a virtual reality. It may seem that a pilot only controls the position of the pointers and aircraft symbols on the instruments and that isn't necessary to use non-instrumental information to create an overall picture of aircraft attitude. But in the event of aviation equipment failure, pilots' work whose actions are regulated only by information from the instruments will be unreliable. Unfortunately, flight practice proves it. The development of the non-standard situation on the board the N148 Saratov Airlines aircraft, a Flight 6W703 Moscow-Orsk, led to tragedy as a result of switched-off pitot heat. Due to the fact that in stressful situations the pilot trusted only speed readings, which as a result of icing were lowered, ignoring non-instrumental signals, G-force which did not change during sharp drop of the speed parameter, the pilot started to descend. Using for instrument mental model only one parameter, he continued to pilot directly at instrument speed. with reliable and stable engines, he tried to accelerate through his actions, and only after flying out of clouds he was able to get an orientation, after which he began to pull the plane out of the dive. But unfortunately, due to a lack of altitude, the crash could no longer be avoided. To understand all the problems associated with spatial disorientation, it's necessary to know the weaknesses of the traditional initial pilot training. The requirements for trainees are often limited only by knowledge of flight parameters and DEFCOM. Also methodically, an expert training organization is added more often than not. The cases where pilots' instructors pay less attention to the necessity of non-instrumental signal usage in visual flight leads to the fact that the process of the flight perceiving development protracts over years. It becomes noticeable straight away because trainees are hard to master flight program with an instructor, often perform hard landings, especially during the first solo flights. Also, the desire of some approved training organizations heads to start training of instruments control without paying serious attention to the essential model development phase in visual flight, thereby weakening resilience in the future, cannot but cause serious concern. Today, from the perspective of the competency-based approach, it's clearly seen what changes in the initial pilot's training are required. The proposed method allows introducing systematics and objectivity into the monitoring of the flight abilities level. Taking into consideration physiological patterns of flight work described by the flight image concept and the sequence presented in the new method, the team of like-minded colleagues has been developing a training program oriented on developing flight abilities for more than 2 years already. The main mission that the educational designers assigned was to provide pilots with training and practical material for the effective performance organization of implementing spatial orientation, primarily in visual distribution and attention switch. Therefore, individual theoretical units will be interesting for all pilots. The work on the program development is in the process of completion and requires an effectiveness analysis before implementation. The training course is designed in such a way that it takes into account all the didactic principles of the training process, so it is suitable both for existing PPL and CPL programs and for the modern training system.